Honestly, you could spend all day talking about factoring, but let's face it, that's something you were supposed to learn last year. I'm just supposed to be reviewing it, so I'm hoping you can help me through it quickly so we can get on to the geometry. How can you factor the first problem? What are the like terms? They don't, but one has a squared and one doesn't. Yes, dear.
You do the two parentheses and then put x and x for the first term and then plus 3 plus 14.
Why is that?
Because 3 times 14 is 42 and 3 plus 14 is.
Do you remember why that only works to those or no?
Because both the positive and the first in the polynomial is the positives equal to positive with the 42 and the positive.
Katie, you're going to be on my nerves.
So,
The reason this works is because the leading coefficient's a 1. So if you have a 1 in front, and this rule always works that Sabby's referencing, you're trying to figure out what adds to give you 17. 3 and 14 give you 17. But hey, so do 16 and 1. And you're trying to figure out what also multiplies to give you 42. 21 and 2 gives you 42. But 21 plus 2 does not give you 17. So it's whatever's going to make both of these facts work. I let first period skip that. And I shouldn't have, because like half of them knew how to do it. And I didn't let you, and here we are. What is the answer on number 2, knowing what Sabdi has said? Why is it G? Why is it G? If it is G, why is it G? -4 times -5 is positive 20. -4 minus -5 is -9. She had her Wheaties this morning. This section might actually be easy for her since she definitely is paying attention in math class. If you don't know how to factor and you're wanting more factoring practice, like I know poor RJ has to factor in Miss Clemens' class that he takes. So if you're wanting more factoring practice, see me. Otherwise, I'm assuming you kind of sort of could figure it out. And obviously the answer is no, because you're hurting my feelings. Get out the blue sheet. Why do some people not have a blue sheet? Get out the little tiny blue sheet. Let's talk about it. Also, how about your notes? Yes. When would be the absolute best time to ask me about the project? That would be true. And then what do I sit in here doing for like 45 minutes in the morning? Yes, that would be like, if you're wanting me to check it and stuff, that'd be when you want to come see me. Okay, so I've been telling you that we're finally not going to talk about the Pythagorean theorem today. So 8-2 was Pythagorean theorem crazy, and the converse, but you understood that. So I know everyone in the room has that down, except there was one person who on their checkpoint kept trying to make X always the C. What has to be the C? Okay, how do you spot the hypotenuse? Okay, so I'm going to go ahead and label my handout. This is the hypotenuse. I'm going to stop writing out the word hypotenuse. I'm just going to start putting HYP. I don't have time to spell it all out anymore. Okay, so everyone has that down. And then we get to this section, which is going to be 45, 45, 90s, and 30, 60, 90s. Today is the easier of the two, actually. And then we'll practice it on Friday. Monday we'll review. Tuesday there'll be a test on just those two sections. So, needless to say, this is very important. And then my second word to wisdom is this: make your handout good. I'm going to offer this. Lord knows I already offered you bonus points to the world, so it's not going to be a bonus or anything. In fact, it's a trade-off. Trey can lose 5 points to use this blue handout on the test, so he's at a 95. But Trey and I both know that I'm a sucker for justification answers, so if he does his justification question really well, he could earn back that lost 5 points in his justification answer. Because if you write a good enough justification answer, I give you bonus every single time. There are some people in the room who get bonus every single time from me because they use their words and they explain themselves. So, if Trey knows he's going to do well on the justification question, he's willing to take that gamble. If not, maybe he won't use the blue handout. But if you know that math tests are hard for you, then I highly recommend taking the 5-point loss and using this blue handout on the test. Okay. Saying that, We have to fill in the blue handout for it to be useful. What do you think we call the other sides of the triangle? We can call them legs. I'm going to call them legs. Why do the two legs match today? Why is there an X on each leg? Why do the two legs match today? Why are the two legs congruent? Because there's two angles that are 45. Again, we talked about that the angle goes with the side across from it. The 90 is the biggest angle. The hypotenuse is the biggest side. There's a reason they're across from each other. 45 goes with this side. Another 45 goes with that side. So no wonder the two legs match, because the two angles match. That makes common sense. Okay, what kind of triangle is this? It is a right triangle, but I'm looking for another word as well. It's isosceles. So this is an isosceles because two of the legs match. An isosceles right triangle. And then for those who still aren't, I want to just make sure everything's on their handout. The legs are congruent, in case you're going to forget that fact. Okay, since the legs are congruent, there are some things I can go ahead and fill in. For instance, we have 4 examples on this paper. If I look down here, I see this leg is 3, so I already know the value of x. It's 3. They have to match. And if you want to fill in all the missing 45s, you can. Again, the reason we know it's a 45, 45, 90 is because 45 plus 90 is 135. 180 minus 135 is 45. No matter what, you know a triangle has 180 degrees. So even if they only write in the one, the other one's also a 45. Okay, what can I put for y on the second one? This one. The legs match. So what should I put for y? 2 square roots of 3. The legs match, so this one is 2 square roots of 3. They have to match. The two legs match. Okay, what were we given on the top 2 examples? Where are the numbers?
Legs.
Okay, so we were given a leg. If you're given a leg, you obviously need to find the hypotenuse. So here is the formula to find the hypotenuse. You're going to need to take your leg and multiply by the square root of 2. It's square root of 2 times the leg. So in this first example, we were given a leg. So to figure out y, which is the hypotenuse, I'm going to do hypotenuse is square root of 2 times my leg. My leg is 3. So I end up getting 3 square roots of 2. 3 times the square root of 2 is 3 square roots of 2. Are there any questions about that? Okay, what was I given on the second example? Was I given the leg or was I given a hypotenuse? Look at your picture. What were you given? The leg. The 2 square roots of 3 is leg. So if you're given a leg, our formula to find the hypotenuse is square root of 2 times your leg. Well, my leg is 2 square roots of 3. Now, I need to zoom in. Now I'm about to pull some voodoo magic. This is stuff you were supposed to learn in algebra. When you multiply radicals together, you multiply the numbers under the radical. Meaning, there's an understood 1 out front. So 1 times 2 is 2. Square root of 2 times square root of 3 is square root of 6. You multiply the numbers under the house together. So again, my formula is take my number, it was 2 square roots of 3, multiply it by square root of 2. If Isaac has this, he's going to get most of his points. But Isaac wants the A, so he's going to go further because he's not done when he's here. We can go one step further, multiply the numbers under the house together. 2 times 3 is 6, so it's 2 square roots of 6. Are there any questions on the first 2? What were we given in the third example? Okay, so if we're given the hypotenuse, we're going to have to do something different. There's a different formula for that. Now, really, if we're being real mathy, they're really the same thing. I'm going to say on the one where we're solving for the hypotenuse, we multiply by the square root of 2. The one we're solving for the leg, we're going to divide by the square root of 2. That's really the difference. So if we're given the hypotenuse, we need the leg. We're going to take our number on the hypotenuse, and instead of multiplying, we divide. So really, deep down, all Skylar's going to do today is she's either going to multiply by the square root of 2, or she's going to divide by the square root of 2. It just depends on which part of the triangle she was given. Okay, so does everyone have that formula down? No one's writing. Okay. If we go to the bottom two, we're given the hypotenuse. So we need to solve for the leg. So the leg is going to be equal to, I take my hypotenuse, which is 4, and I divide by the square root of 2. I'm going to work the other example as well. If I'm given my hypotenuse, to solve for that leg, I'm going to take my hypotenuse, 10 square roots of 2, and I'm going to divide by the square root of 2. Now, one of these is going to work out nicely, and one of these is going to require a little extra work. Why? Even though the second one looks scary, why is it a nicer problem? What happens? What happens with the square roots of 2? They're going to cancel out. So my final answer is just going to be 10. The leg is 10, so both x and y are both 10. That one's nicer. It didn't look it. I thought when I saw a scary looking number on the hypotenuse that this was going to be a hard problem. But actually, the scary thing today is that the hard problems are the ones with a pretty number on the hypotenuse. Okay, I don't know why math people make rules the way they do. I did not invent math. I just use it all the time. They have rules like you can't have a negative exponent, and they also have a rule that you can't have a square root in the denominator. So we have an issue in the denominator. If Skylar's wanting to get all her points, denominator. If Skylar's wanting to get all her points, she can't leave it like this. We don't like having a square root of 2 in the denominator. We've got to fix it. So again, Skylar might want to really consider using her handout on the test, because if she ever sees another problem like this, she can always reference her handout and follow the same steps. Okay, so to fix the issue, what we do, and it seems kind of crazy, is we multiply by 1, because square root of 2 over square root of 2 is 1. I'm going to multiply the top and the bottom by that issue. And it's all going to work out in just a second, but I'm going to multiply the top and the bottom by that issue. And then I'm going to multiply straight across. So 4 times square root of 2 is 4 square roots of 2. Square root of 2 times square root of 2, that's square root of 4. And you would say, Miss Compton, hold up a second. You said we couldn't have the radical in the denominator. We couldn't have that square root down there. You still have a square root down there. So you're not done. No, I'm not done. I know the square root of 4. What is the square root of 4? 2. So I actually have 4 square roots of 2 over 2. Issue resolved. Am I done? No. 4 divided by 2 simplifies. 4 divided by 2 is 2. My answer is actually 2 square roots of 2. So again, and I might even make a note to myself, the third example is the kind to beware. The hardest problems are today. The hardest problems from today will be when there is a pretty number on the hypotenuse. Let me say my full speech, David, and I'll answer any question you have. The hardest ones are when we have a pretty number on the hypotenuse. We have to get rid of that issue in the denominator. And the only way to get rid of it is to multiply the top and bottom by that issue. I multiplied straight across. 4 square roots of 2 is 4 square roots of 2. Square root of 2, that's square root of 4. I know the square root of 4, that's 2. 4 divided by 2 is 2. Are there any questions about the beware one? Okay, David, you had a question.
Like, wouldn't the 2's cancel out if you were dividing the 4 square root of 2 divided by 2? I don't know. No.
Yes, and if we did, then we would end up back with 4 over square root of 2. So I completely agree with you, but then we're back with our issue. So our whole point in doing this is to get rid of the issue in the bottom. I know that sounds crazy that we're okay with it in the top, but it's in the rules of math. Dear.
Always multiply like that way instead of crossing it?
Yes, I always multiply straight across. 4 square root of 2, 4 square root. I always multiply straight across. Yes. Okay, now we're about to do 4 more together. And then I'll give you some for you to do. But I swear I'm going to do it until we die. So, example 1. What are we given? We're given a leg. So if Nick's wanting to prove to me that he can get points, the first thing Nick's going to do is, even though it says solve for x, he's going to put in a 9. He wants me to at least know that he understands both legs match. Okay, so we're given a leg, so what formula do I need to use? Okay. Now, do I write the formula every time? No. Am I writing it every time now to prove a point? Yes. If Elena realizes there's a pattern, because there is a definite pattern. If she realizes there's a pattern and she figures it out and she doesn't want to show her work, she knows she didn't have to. Then there's the issue of what if she makes mistakes, we're all human, then she's going to get counted off more, whereas if she just showed me a little work or at least showed me a formula of something. Okay, so I'm going to do square root of 2 times 9. What is my final answer? 9 square roots of 2. So the hypotenuse is 9 square roots of 2. Notice our triangle is 9 square roots of 2. Okay, what were we given on our second example? Okay, so we're given the leg. So I need the formula for the hypotenuse. We're given a leg. So again, I'm going to need to do hypotenuse is square root of 2 times my leg. Well, my leg is 6 square roots of 2. What am I going to get on the next step? I'm going to get 6 square roots of 4 because 2 times 2 is 4. I'm not going to leave my answer like that, though. Why not? 4 is a perfect square. What is the square root of 4? So what's my final answer actually going to be? 8? 12. We're going to multiply them together. 6 times 2 is 12. That's totally understandable. Okay, so life seems pretty great if they give you a leg. And then we get to number 3. Did they give you a leg? No, you were given the hypotenuse. Is this a beware problem or no? Yes, if there is a pretty number on the hypotenuse, like an 8, then it's a beware problem because it's going to require a little extra work. And then I just pointing out this pattern to those who are interested. Notice the last triangle was 6 square roots of 2, 6 square roots of 2, 12. It was 6 doubled is 12. Interesting thing going on. Okay, so if you're given a hypotenuse, what is the formula for the leg? Okay, so we've been multiplying by square root of 2. Now we're going to divide. So I'm going to take 8 and divide by the square root of 2. Can Alex leave his answer like this and get all of his points? No, I have an issue with that square root in the denominator. He needs to multiply both the numerator and the denominator by that issue. He needs to multiply straight across. 8 times square root of 2 is 8 square roots of 2. Square root of 2 times square root of 2 is square root of 4. What is the square root of 4? Okay, I got to move my answer over a little. I'm going to run out of room. So I have 8 square roots of 2 over 2. And then thankfully that simplifies even further. Because 8 divided by 2 is 4, so I end up getting 4 square roots of 2. So let's say that all again. Alex can't leave his answer like that. He has to multiply by the issue. He multiplies straight across. He knows the square root of 4, that's 2. He knows 8 divided by 2 is 4. Are there any questions on this third one? I've got one left, and then I'm going to assume you have it. I'm going to give you a couple to try, but we shall see. Because Lord knows if there's a section you could blow it on, this one's it. This one's it. Okay, let's flip. Okay, what were we given? Should we be scared? Yes, why? It's a pretty whole number like 6. So we need to use that formula where are we going to multiply or divide? If you're given the leg, you're given the hypotenuse, you have to divide by the square root of 2. So we're going to divide. That's why it's a problem. We can't leave our answer like this. So we have to multiply the top and the bottom by whatever that issue is. And our issue right now is square root of 2. So we get 6 square roots of 2 over 2 times 2 is 4, square root of 4. I know the square root of 4. That's 2. I know 6 divided by 2 is 3. So I get 3 square roots of 2 for both legs. Notice that 3 times 2 is 6. 3 square roots of 2, 3 square roots of 2, and then the hypotenuse is 6. There is a pattern. If you notice a pattern, go for it. Some people are never, ever going to notice the pattern, and that's fine. They'll always use formulas. It's not a big deal. Okay, so I'm going to get Danny to give you this paper. Obviously, we not talked about 30, 60, 90 today. You can't do that yet. I need you to at least do the top 6 to 45, 45, 90. If you're trying to get ahead on your life and you're not wanting any homework this weekend, because Lord knows I'm full of practice worksheets on this, because Addison's got to practice it to get it down, she should probably go ahead and flip the paper over after that and do the 45, 45, 90s in this maze thing. I get she can't do the 30, 60, 90s, but by golly, she can do the 45, 45, 90s. She's that good. Engineer. While she does that, let me make my last pitch to you. On Friday, the money is due for the Earth Day shirts. I've only sold 3.